Alright guys, welcome to another class. So we've been treating exponential function for quite a while now, right? And mind you, the links to all the videos will be on the description box of this video, right? To make sure you understand what we're doing from other steps, everything we've been doing on exponential function from the beginning, from the very first video, so that you can understand how this thing works, right? Because I've been getting messages on it's a bit advanced, stuff like that. So trust me, we've worked on everything, and then if you just go to the description box of this video, you're going to see the links of all the former videos we've been doing, right? To make sure you understand, to get you to expand your understanding on what we've been doing. Let's get to the last question of this video. It said if f of x, and mind you, hope you know that f of s is the same thing as y. Right, let's just get this straightened up, that y is the same thing as f of s, and I've taught this extensively in some of our calculuses video, right? But this is not what we're looking at. We're looking at something else. Let's take some. Now we're looking at, so let's get down to this now. It said if f of s, which is y, and you say if y, which is this, is equal to the exponential function of the power, solve for the first and second derivative of the function, first and second derivative. So we're looking for dy over dx, the first derivative being dy over dx, or f of single prime of x, and then the second derivative being d square y over dx square, right? Or second prime of x. That's what we're asked to look for, right? So we're going to try and be fast as possible as we can to make sure you understand what we're doing, and I've explained all of this in previous video, right? So let's take it step by step. Remember we said step one is to do what? Is to make u this, substitute this for u, or the power here, right? So we can say let u be equal to the index, and these are the index, right? So what's the index? The index there is 6x raised to the power of 4 plus what? 3x raised to the power of 3 minus 6x raised to the power of 2 plus 2x plus 6. Alright, this is the index. So what do? We differentiate u with respect to x. I differentiate u. So our step two is to differentiate u with respect to s. So we differentiate u with respect to x. And how do we do that? We'll say du, that's u with respect to s, over dx becomes what? How do we differentiate this? It's 4 times 6, which is 24. 24x, 4 minus 1, which is 3. And then what? Plus 3 times 3, we have 9x, 3 minus 1, that's 2. Minus 6 times 2, giving us what? 12x, 2 minus 1, that's 1. And then plus what? 2x. If you differentiate this, I said if you differentiate a single variable, we just have 2, and a constant variable will give us 0. If you differentiate it, we have 0, and I've explained that extensively on the previous calculuses video we've been doing. Alright, so we have this, that's our step 2, step 1 and step 2. Alright, so now know what du dx is now. Alright, so what becomes our step 3? Our step 3 is simply to bring out this, but replace this with u, right? To bring out the equation, right? What's the equation? The equation is f of s, or y is f of x. So let's just use y. Let's say y is equal to e raised to power the function. But with step 3, we are replacing the function, what we have here, as u. Instead of that, we replace it as u, because we said u is everything here, right? So this u is everything there, just replacing it, right? And then we differentiate. Right? We differentiate y with respect to u. So that we have dy over du is what? The same function, e raised to power u. I told you if we differentiate an exponential function, we're going to have the same function, and I gave you an extensive proof on how that works. I'm also going to be leaving the links of that video in the description box of this video, so that you can understand what we are doing, right? So having differentiated, we bring the formula. Step 4 is to invoke the formula. Our step 4, which is the final step, is to do the formula. What's the formula for function of function? Because all we're doing is function of function, right? So the formula there is dy over dx is what? Dy over du times du over dx. See, is that easy? So let's replace now. What is dy over du? That's what we have here, which is e raised to the power of u. E raised to the power of u times, what's our du over dx? We have it here as what? This is our du over dx, right? And this is our dy over du. These are what we are replacing. So it's du over dx, which is what? We have 24 x raised to power 3 plus 9x raised to power 2 minus 12x plus 2. You see, that's the final answer. But we arrange, right? Just rearrange so that we now have the answer dy over dx will give us what? Let's bring this one first. Is 24x raised to power 3, right? Plus what? 9x raised to power 2, and then plus what? A minus, sorry, I have minus. A minus 12x, then what? Plus 2 e raised to the power of u. See, I just rearranged by bringing this one first. But then we know what u is, alright? We know that u is basically everything, this value we have here. So let's just put everything in the box. Final answer, we're going to have our dy over dx as what? 24x cubed plus 9x squared minus 12x plus 2 e raised to the power of what? E raised to the power of everything here, which is 6x raised to the power 4 plus 3x raised to the power 3 minus 6x squared plus what? 2x plus 6. That's everything. And I taught you this. Remember, I showed you all of this. Right? I've explained this. It's our answer. I've explained all of this for you. Right? So this is not hard. This is the first derivative. Remember, we're doing the first derivative and the second derivative. So by applying the formulas or by going through the steps, number one, we said the first thing to do is to let u replace the index with an alphabet, and we're using u as our alphabet, right? So let u be everything here. Next is to differentiate u with the alphabet, with the index, right? Differentiating u with respect to x. That's what we just did here. Exercise step 2, differentiate u with respect to x. Du dx, if you do that, I've taught you all of this. If you go to the channel, you're going to see where I taught you how to derive with what their general formula is by using this to multiply this. That's what? 24, and then 4 minus 1, and 3 times 3 9, 3 minus 1, 2 times 6 is 12, 2 minus 1, and then 2 times 1 is 2, right? And then 1 minus 1 is 0. This one is also 0. Constant number is always 0 if you differentiate a constant number. Step 3 is to bring out this the formula again, or the question again. That's e, y being e raised to the power u, and then you differentiate it. By differentiating it, you have e raised to the power u. Step 4, you use the formula, which is